Okay, today we're going to finish up on the planes and equations of planes, and I was getting to area of planes yesterday, but I ran out of memory. Apologize. It's my old phone. All right, let's say we have triangle ABC, and we know that the area is 1/2 base height. Everybody knows that. Well, that base is vector AB. And the height this is vector AC right here. So the height is the base, I should say the magnitude of vector AB. The height is magnitude of AC sine theta, where that's theta. This is in a right triangle here. So this can be thought of as 1/2 times the base times the height. Which, of course, this is not the 1/2, is the definition of the magnitude of the cross product of AB and AC. And if you look in the book, they also talk about the parallelogram that contains, something like this. And that's just without the 1/2 on it. It's no big deal. You should be able to figure that out if you've read the book. Okay, this is very useful because in 3 dimensions, it's really difficult to find a geometric perspective on all this stuff. But if you just know the 3 points, all you have to do is know cross product techniques, and you can find the area of a triangle that's formed by 3 points in space by this simple technique. Now, here's an example. Now, the book examples they have, and I'll do a book example too, but the numbers they give you they're difficult to deal with. I mean, they're not difficult to deal with, but there's no way to visualize what's going on there. Okay, so we'll do something that can be visualized. All right, so do our little picture. All right, I'll flip this over and start on the back because it might take a little bit more space. All right. Okay, let's say that we have a triangle that has on it the points 5, 0, 0, 0, 5, 0, and 0, 0, 5. Okay, and it would look like this. And it's, the portion of a plane that's in the first quadrant, first octant, I should say. Okay, and this is an equilateral triangle, and we'll figure the area of this by equilateral triangle here in a second, just to show that the method works. All right, so let's call these points A, B, and C. Now, vector AB is negative 5i plus 5j. Vector AC is negative 5i plus 5k. And again, I'm not going to write zeros in when I write these vectors because it really just shouldn't be done. Okay, if I take the cross product of AB with AC, I hope everybody was following my good and valuable advice. And writing all this stuff out, before you do any multiplication, write it down, and then all you have to do is put the numbers in. Okay. And again, the I vector is formed by the interaction of j and k. So we got 25 and 0. J formed by I and k. Negative 25 and 0. And k vector formed by these, 0 and negative 25. So this turns out to be 25i plus 25j plus 25k. Okay, now if you think about it, that should be, if you visualize this, if I draw a normal vector off of here, I say this is a point on the plane. This vector is pointing in positive, it's pointing in the positive direction in all three I, j, and k. So that makes sense, I think. And, really, when we draw this, if we're going to draw a normal vector, we should draw a perpendicular sign as well. And you practice drawing your perpendicular signs. It's not an art form or anything like that, but it's if you draw it, this line should be parallel to that whatever you drew as that edge. And we'll talk about some drawing techniques when we have a project in this unit, and it's an extensive project. And drawing is part of it, and you're going to have to turn it into drawing, but it'll be a group project. All right, but we're getting ahead of ourselves a little bit here. All right, so if I want to find the area of triangle ABC, it's 1/2 of the magnitude of this cross product. Okay, or 1/2 times the square root of 25 squared plus 25 squared plus 25 squared, which is 3 times 25 squared. Okay. So that's 1/2 times, and the square root of 25 squared, of course, is 25 times the square root of 3. Okay. So that's, and you should see where this is coming from. Instead of adding all those numbers together, I just wrote it as 3 times 25 squared. And we'll see why here in a second. Okay, now, if we take a look at that triangle, consider that this is a right triangle, this base. Okay, that's a side of 5, and that's side of 5. So this is a 45, 45, 90 triangle here. So this distance right here has to be 5 squared root of 2. So I'm going to redraw my triangle down here. And this is point A, B, and C. That base is 5 squared root of 2. This is equilateral. It has to be equilateral because, I could do the same thing. I could say this is a right triangle and so on and so forth. So I can split this in half. That makes this a 30, 60, 90 triangle where there's the 60. So this distance right here is 5 squared root of 2 over 2. And then this height is 5 squared root of 2 over 2 times the square root of 3. So the area of this triangle is equal to 1/2 times the base times the height. All right, so we got a 1/2. We got 5 times 5, which is 25. Square root of 2 times square root of 2 is 2. We got 1/2 times 1/2, so here we'll make this 1/4. And then I've got the square root of 3. All right, the 2, so we get 1/2 times 25 times the square root of 3, which is exactly what we got up here. Okay, now you might say, well, why wouldn't we just find this area by conventional geometric techniques? Yeah, you probably should in this case because it's pretty easy to do, although that's not very hard either, to tell you the truth. But for problems where it's very difficult to visualize how this is all fitting together, this technique is much better. At least I think so. All right, but while we're at it, let's find the equation of this plane that contains those 3 points. All right, now, again, and I like to bring this up. If I have the normal vector, and it is 25i plus 25j plus 25k, I'm better off going with this normal vector. I could divide that down. It's because, again, and I've emphasized this multiple times, if you're interested in the direction of something, the size of the vector makes no difference. If you're interested in the length of the vector, of course you have to take, the actual vector and its length. But the only thing we're interested in here is the normal vector. I could use 25, 25, 20. I could use 100, 100, 100. It wouldn't make any difference about what's going to happen next, because the coefficients here are x plus y plus z, and we need a d. Now, any of these 3 points will suffice. If I put the 5, 0, 0 in, I'm going to have a 5 here and then 2 zeros. If I put 0, 5, 0, I'm going to have 0, a 5, and a 0. It doesn't really make any difference, so I'm going to get d is equal to 5. So the equation of this plane is x plus y plus z is equal to 5. Now, I do apologize because my visual aids that I have in the classroom, the three-dimensional coordinate system, I have a plane that fits in there real nicely, and it is this plane. And it's easier to see, but I'm limited here, folks. I am limited. Okay, so we will also do an example that's one of the book problems. Now that one's going to be, the numbers aren't going to work out so perfectly. Well, they work out okay, but they, it's not a. If I have it, I have to make sure I have it, because. If I don't want to be doing it, because I don't want to make any mistakes. Let's see here. That's not it. That's not it. Yeah, well, I don't have it. That's just great. And the way these video things work, if you pause it, you're done. You can't come back to it. All right. And it is not here. Oh, no, wait a minute. There it is. Sorry about that delay. Okay, problem number 16. Given 3 points, and they are 7, 8, 11, negative 4, 2, 1, and 3, 8, 2. Okay, find the area of this triangle. All right, well, you don't need to use AB and AC. You can use BC and BA. You could use AB and CA. It doesn't make any difference, really. You will get the exact same number. You get the exact same plane every time. There's no other way around it, and for obvious reasons. Okay, but we'll just use AB and AC. So AB is negative 4 minus 7, negative 11i, 2 minus 8, negative 6j, 1 minus 11, negative 10k. AC, 3 minus 7, negative 4i. 8 minus 8, which is 0, which is always convenient to have a 0. 2 minus 11, negative 9k. All right. Almost put a plus there. And I hope everybody reviewed my document and the examples in the book as to how this came about, I hope everybody else is convinced that writing it in this format really is helpful. I've found that over I guess, all right. Some people don't think so, but I really do. Okay, 6 times 9, 54, that's a positive. Okay. 11 times 9, negative 11 times negative 9, that's 99. Minus positive 40. And then 0, positive 24. So this is 54i minus 59j minus 24k. All right, that is the normal vector to this plane. It's also the components, or the coefficients, I should say, of the x, y, and z variables in the equation of the plane. This problem, however, did not ask for the equation of that plane. So the only thing we're interested in here is the area, which is 1/2 of the magnitude of the vector 54i minus 59j minus 24k. And if you square all three of those things and add them up, it turns out to be 6973. All right, and that's approximately 41.7 square units. This is why I say I didn't really want to go through this unless I had the answer sitting here, because I didn't feel like getting the calculator out and doing all this work, because I would surely have screwed something up. That's one thing. I really don't like the book's problems for this section, because I think they make the numbers too difficult. The example I gave, I think, is better. And it's always nice to work some zeros in there. First of all, because I've been, harping on this. It's better to work with some of these cases where the zeros are involved, because it actually makes it conceptually more difficult. This type of stuff, you're really not going to try to visualize that triangle. There's just no way of doing it. I mean, some people probably could at least see some of it. But it's really, really hard to visualize in 3D by just looking at points like this. It's quite difficult, because you can't gain any kind of perspective on distances. All right, well, you have problem number 15. Which is like this. And I also want you to do numbers 19 and 20 in section 12.6, and I screwed that up on Dashboard this morning. I did change it. Okay, 19 and 20. I'm not going to go over these problems, and they involve a little bit of work, but they're sort of a compare and contrast of dot product and cross product. And like if you take the cross product of the two vectors here, you're going to get this vector, which is perpendicular to both of those. And I did some of that work yesterday in the video. So you'll find that once you take these cross products, you're going to take dot products, and you're going to have perpendicular vectors, and that's exactly what you want. But there's also another element to that, is by the definition of the magnitude of the cross product is magnitude A, magnitude B, sine theta. Now, if two vectors are parallel, there's another relationship that shows up. So these problem numbers 19 and 20, they're asking you to sort of explore the relationships between parallel and perpendicular type vectors. So I'm not going to go through the examples, because it would, none of it's really hard. You can find this as you do them. Okay, so that is for tomorrow. Okay, that'll be assigned tomorrow. And then on Wednesday, there won't be any assignment. So you'll be consolidating your homework Wednesday, and I'll open that up to turn it in. I'd like you to turn it in Wednesday. You should, and I will post a document with a list of all of the homework on, like we used to have on the board. I'll just write it down, and I'll give it, and I'll put it up on the assignment when I post the assignment. And then on Thursday, a quiz. Now, at least one person has got a hold of me and said that they have an AP exam that day, and there's really nothing much I can do about that. You can take the quiz whenever you want to take the quiz. I ask you to stay with the 47-minute thing, but I have no way of policing that. So you can take it whenever it's convenient for you, and hand it in. And there's really no punishment for somebody to hand something in a day late or anything like that. Okay, if you have any questions, post them or send me email.